Hello, my name is Norm Johansson, a senior software engineer at AWS, where I focus on all the .NET tooling here at AWS. Today, we're going to talk about building modern serverless applications in .NET Core 2.0. Before we do that, we need to get our tools set up. So the most important tool for Visual Studio users is to install the AWS Toolkit for Visual Studio 2017. You can do that by going up to the Tools and Extensions menu item, searching for AWS, and you'll find the AWS Toolkit. Click that to install. Once that's installed, in the AWS Explorer, you can import your AWS credentials to start developing AWS right from there. If you're not a Visual Studio user, you can also use our tooling that we've added for the command line. All of the projects that you'll see us create in Visual Studio, you can also do from the command line in the .NET New command. To install those templates, you'd run .NET New -I for install, Amazon Lambda templates, and that'll create all the projects in there. And then to create an actual project, you would run .NET New, the name of the project, and then you could specify the region you want the project configured. Each of our blueprints that we have set up have a reference to the Amazon Lambda tools in its CS project file. What that does is it allows the .NET command line to have a Lambda command to deploy your functions. So with that reference in there, you can run .NET Lambda to deploy function to run the same deployment that we have in Visual Studio. Now with those tools set up, let's take a look at how we can start deploying our functions. Now here I have Visual Studio, and we can see we have the AWS Explorer here on the right, all configured. And I can start creating a Lambda project by saying File, New Project. And under C# here, we have the AWS Lambda node. We have the AWS Lambda project and the AWS Serverless project. The Lambda project is where you would create an individual Lambda function, deploy that to Lambda, and then set up all the event sources for that Lambda project. A serverless application is where you might create a collection of Lambda functions and declare other AWS resources and deploy those all together with a CloudFormation template. So let's just select the Lambda project. And here we have some blueprints to help get starting with our Lambda functions. So for example, we could create the simple S3 function to create a project which has all the initial code set up for listening to S3 events. And we click Finish, and that will create our Lambda project for us. And here we have in the Solution Explorer. Now I've already actually created a project. I'm going to switch to another Visual Studio that I've got a project all set up here. And this project is going to do the classic example of using Lambda to generate thumbnails uploaded to, create thumbnails for images that were uploaded to an S3 bucket. Here we have our function CS. So this is the code that we want Lambda to run. First line here is registering a serializer, which is going to allow Lambda to serialize the streams of data coming into our Lambda function into a .NET object, as well as it will serialize the response object back from the .NET object to the stream that Lambda expects. Then we have our default constructor here. That's going to be called the first time this Lambda is called for a Lambda compute environment. And this is a good place to do any of your initialization work that you don't want to do for every single function invocation. In this example, we are registering the AWS SDK with the X-Ray service. So this is how we're going to be able to use X-Ray to get an overview of how our serverless application is using other AWS services. And then we are creating an S3 client. Now, since we've done that after the registration here, that means that this S3 client is going to be pre-configured to send its tracing data to X-Ray. And this is only going to happen during that first invocation. Now, if we skip down to our actual Lambda function here, so this is what's going to be called for every single one of our events coming in. And this is going to be taking S3 events. It's going to loop through all the records coming in there. We're going to make sure that the file type of the object uploaded to S3 is an actual image that we support. And then we're going to get our object from S3. And then we're going to use a library out there called magic.net to do our image manipulation. Now, .NET Core doesn't have the system drawing class as .NET Framework does, but this NuGet library will allow us to do those similar image manipulations that we would do in .NET Framework. Now notice I have wrapped this code around a begin subsegment from X-ray and an ending down here. This is going to allow me to get tracing information to know how long it's taking for this library to do the creation of the thumbnail. Now once we have the thumbnail, we're going to go back to our S3 client and we're going to put that object under a thumbnails folder in our S3 bucket. And that's all we need to do. Another file that was added to our project as part of the blueprint is this AWS Lambda Tools defaults file. This file is created to set up a lot of the initial settings that we would use for our Lambda function. It also allows us to persist the settings so we can easily redeploy this in the future. So when we right-click on our Lambda function and select Publish to AWS Lambda, a lot of these fields are already filled in for us because they came from that defaults file. So now we just need to give our function name. I'm just going to call this the image resizer. Notice the checkbox here is set to save all the settings in the wizard so that when we redeploy, we can just have everything preset for us. On the next page, we need to specify the IAM role, the identity access management role, that we want Lambda to assume when invoking our function. And this is what's going to provide our Lambda function access to AWS services, like S3 in this example. We could create a new role here, but I'm going to select a role that I already set up before today's webinar. Everything else here I can leave at the defaults, except I do want to enable active tracing for AWS X-ray. So we instrumented our code to send the tracing data, but we needed to tell the Lambda environment to enable the X-ray daemon on it. And that, we're going to push upload, and that's going to begin our function deployment. What this is doing is it's using the .NET CLI to publish up our application, and then it's going to call the create new Lambda function API from the Lambda service. Now it's telling us the default file got updated because all of the settings from the wizard just got persisted into that file. And now we have our view of our Lambda function, which came from the AWS Explorer. I could, in this first tab here, I could test my Lambda function. I could create a version of that input request. Like here's what an S3 put looks like. Set those fields on there and go ahead and invoke my function from here. I could change some of the configurations. What I want to do now is actually set up our event source. I want to set up the S3 bucket that we want to listen to. So first, let's create a bucket. So I'm going to right-click here. I'm going to call this the NormJ webinar bucket. And push OK. So our bucket's created. And now, let's set up the event source. So we'll select the bucket we just created. And I don't want every object uploaded to this bucket to invoke our Lambda function. I only want objects that are uploaded with a prefix of images to have our Lambda function be called. And we'll say OK. And so now that is all set up for us. And we can test that by opening our bucket, creating a folder, images. And then I have some images here that I'm going to copy over. So now as these images are being uploaded to our S3 bucket, it is triggering events that is causing our Lambda function to be invoked. And it's going to invoke, for each one of these, it's going to go create thumbnails. For example, here's a picture of Mount Rainier, and we can see it's full size. Now, if we switch back, we should have a thumbnails folder now. We click on the same picture, and now we have our thumbnail. Okay. So that's how we can create a function right here in Visual Studio and deploy it and start doing some of our testing here. Another feature that we just launched recently was the ability to write Lambda functions using F#. Now I could go ahead and do that right here in Visual Studio by saying add new project under other projects, F#. We have those same project templates out there, but let's show how we can do this from the command line. So we'll switch over to my command prompt. And first, let's install the project templates here. So I would say .NET new -I to say install Amazon Lambda templates. And that has now installed all of the blueprints that we have inside Visual Studio also into the .NET new command. And you can see several of these do have support for F# as well. Let's take a look at creating the detect labels blueprint. We're going to do this in F#. To create that project, we're going to say .NET new, the name of the template we want to use. We want to say our language is F#. And I want to configure this for US East 1. And then I'm going to name this project Detect Labels. Oh. And I think it's only 1 dash. There we go. So now, if we go into our Detect Labels folder, and let's just bring up Visual Studio Code to see what we've created. So the blueprint created both a test project and our source project. And we can see here's our F# project. We have that same serializer. We have a default constructor. And in that constructor, we're creating an S3 client and an image recognition client. And then our actual function that's going to be called every time, we're going to go use that client to detect labels from the image recognition service. Then we're going to convert those labels into an S3 tags collection. And with that tag collection, we're going to go call the put object tagging operation to add those tags to our object. Now we had X-ray configured in our image resizer. Let's add that support here. So first we need to add the project reference to the X-ray service. I'm going to switch back over and copy the reference from my previous project. So this is adding the AWS SDK handler to this project. And then in my constructor, I need to go and register X-ray with the SDK. And I can copy that same line again. And that's all we need to do for configuring X-ray. Now I could set up F# or Visual Studio Code to do all of my building from here. But let's switch back to the command line to show how we could deploy this using our Amazon Lambda tools. So we need to go into that directory of our project. We're going to do a .NET restore to make sure our Amazon Lambda tools NuGet package has been downloaded. And now if we say .NET Lambda, you can see we have several command options here. The first set of options are being able to interact with the Lambda service itself, deploying functions, invoking, and listing functions. The second set is a set of commands you would use for serverless applications. This is where you're going to deploy with a CloudFormation template. These bottom two are utility commands you can use for when you want to use our command line tools in your CI/CD system. We'll take a look at those later in this talk. So we're going to just deploy straight to Lambda. So we're going to look at how that works. So .NET Lambda deploy function. And let's look at the options for this. Okay, these are all the command line options to specifying our Lambda function deployment. Now, most of these we don't have to set because they were set in that defaults file in our project. again, if we look back in Visual Studio Code, we can see we already have the function handler, our memory size, our timeout. All those things are set on there. So we don't have to set all those on the command line. Although if we want to override those, we could specify them on the command line, and they would override whatever in the file. Now, when you run the .NET Lambda deploy function, and any required parameters you have not specified, it will ask you for those. But we do have one optional parameter I do want to set, which is the tracing mode. This is, again, what's going to turn on X-ray on the Lambda service. We're going to say .NET Lambda deploy function, and let's call this function detect labels. And turn tracing mode is active. And it's from this. Now this is going to run that same deployment we do in Visual Studio. And this is an easy way to work back and forth between Visual Studio and the command line. Oh, it looks like I didn't save my project file. Let me go back over there. Okay. And we'll rerun that same deployment. Now the role, the IAM role, is a required field, and we didn't specify it. So the toolkit, or the command line tool, is going to prompt you for the role. I could create a role, but I'm just going to go and select the role that we already set up before. And now our Lambda function is created. We could go .NET Lambda list functions. And we see these are the two functions that we have deployed so far. Now let's go set up the event sources for this. So we'll go back to Visual Studio. If we right-click here, here's our detect labels. We'll set up our event source. And we're going to select that same bucket we did before, the NormJ webinar. And now we want to listen to when objects are uploaded with a thumbnails prefix in it. So the first Lambda function is going to be invoked when objects are uploaded with the images prefix. And then the second one is going to be invoked when objects are uploaded to the thumbnails. So this is how we kind of chained our Lambda functions together. So now if we go back to our S3 bucket, and let's just go ahead and clear these out. We'll create our images folder again. Now let's see what happens when we upload all these images again. So now our images are being uploaded, which is causing the resizer Lambda function to be invoked. Once it uploads to the thumbnails, those folder, it causes our detect labels Lambda function to run, which will then create our image tags. So if we go back here and select thumbnails, and if we look at Snoqualmie Falls, we can look at properties and tags, and we can see that it's outdoors, it's waterfall, all those things that we copied over. If we look back at our Lambda function itself, we can also look at the logs information here and see some of that data here. So we can see here is all of the logging we did from our Lambda function being outputted here. So it's how we can use that for debugging there. Now we've got our two Lambda functions that are setting up our images, creating thumbnails, and categorizing with labels. Let's look at how we could create a front end for this. Now here is an AWS Code Core website. And the first thing we have in here is I need in the app settings here to specify what is the bucket that we're going to use to show everything. And we've used the bucket NormJ webinar. Now this is just a regular ASP.NET web application that I can actually just go F5 and run it right here in Visual Studio. and debug it in development, just like any regular asymmetric application. So here it is, listing all of our thumbnails from our bucket, and we can click on the red rocks from Las Vegas and see that this is, again, mountains and nature and canyons. So that's pulling our tags there. Now I'm showing this as an asymmetric application because what we're going to do is we're going to deploy this whole asymmetric application as a Lambda function. And we can do that by adding the NuGet library Amazon Lambda AWS Net Core server to our project. And then we add a new class into our project. I typically call it the Lambda entry point, which acts very similar to with the same thing as the program CS file. This is the main point where you get called. Now what this class has got to do is it's going to extend from this API gateway proxy function, which comes from that NuGet library, and that actually contains a method called function handler async. That's the actual function that will be called every time by Lambda. And the operation we have to override here is the init method to set up how we want our web host builder to be configured, which is very similar to how that is done in the program CS file, where it's setting that up. Typically, the only thing we need to set up here is what is the startup class. And after that, there's no other changes to this project to make it Lambda specific. We can look at our startup class. Here's where I initialize X-Ray for this, so all my service clients are configured will be using X-Ray. And then I've added my S3 service client to the dependency injection. All this is the usual things that we would use for AWS Net Core application. Now to deploy this, we're going to deploy this as a serverless application with a CloudFormation template. I'm going to start deploying this now, and then as it's deploying, we'll take a look at the CloudFormation template. To deploy it, we're going to right-click on that project and say Publish to AWS Lambda. Notice I also have the Beanstalk option because this is an AWS Net Core web application, which you can also deploy to Lambda. But we're going to select Lambda. And then we have to give our CloudFormation stack name. So we're going to call this our front end. And I need to specify an S3 bucket that I can use to store the application bits. So what happens is when we do a deployment, we're going to do the .NET publish, zip everything up, upload it to this bucket, that bundle, and then we're going to go and update the serverless template, our CloudFormation template, where anytime it's referencing a Lambda function to point to that bucket or that object we just loaded to S3 as the code location. So let's push publish and see how that works. So here's how the .NET publish is going. And now it's initiating the CloudFormation deployment. And now that's going, CloudFormation is going to start spinning up the resources that are declared in that CloudFormation template. Let's go take a look at the serverless template while it's doing that. Now this template is actually pretty simple. It only has one resource here. And this one is of type serverless function, which is actually a meta resource, meaning this resource is going to get transformed into other CloudFormation resources, like a Lambda function and an API gateway REST API set up by these events. The transform is initiated by the fact that we've declared to use the serverless transform. And then when we deploy to Lambda, we tell it to go create a change set, which is where it will run the transformations. And then once we're created the change set, we tell it to go execute that change set. Now again, if we look here, we can see here is the code URI. So the deployment tool has updated this field to where we uploaded our bundle in the bucket we selected. Now our events field, we have two things set up here. The first is we're going to extend all of the requests coming just from the root to our Lambda function, as well as with this proxy indicator any other requests coming past the root of the URL. And this is because we're going to allow the ASP.NET Core framework to handle the routing of our requests into the appropriate ASP.NET Core controllers. Now this should have run. There it is. It's all completed. And we can click on that. And here is now our serverless ASP.NET Core application showing our images that we uploaded with their thumbnails and their categories. I'm going to click around here a little bit to generate some X-ray data so we can go check at the X-ray console to see how our application is using things. That should be good enough. Let's go back to the console and we'll select X-ray. And I'm going to update this to be the last 30 minutes because of how long we've been talking. And here we can see the distribution of our usage in our serverless application. We have here is our front end coming in, which has got its Lambda function talking to S3. We have our detect labels Lambda function, which is using S3 and image recognition. Here's our image resizer going in and using S3. Let's take a look at the tracing data for the image resizer. We click on that, look at one of our trace data. And remember, we add that logic around in our code to signify what was the image resizer. So here we can see on the graph how long was spent just doing the image resizing. So with the registration, we got all of the service clients for free, but any special code, we can also wrap around and begin and end subsegments to see that in the trace data. Now we've talked about how we can do everything from the command line in Visual Studio, and those are great tools for learning how to use the tools and exploring what's possible. But a lot of you will want to also move to doing this through some sort of CI/CD system. So let's take a look at how we could do that with AWS. So with AWS, we have the AWS Code Services. We've got code commit for source code control. We have code build as our Docker-based build system, and code pipeline, which you can use to connect our source, build, and deployment all together. Code pipeline does support other third-party providers, but for today, we're going to use all of the code services. Now, how you would do a serverless deployment for .NET Core is you're going to create a pipeline that looks something like this, where we're going to have our code commit repository, which is going to have our .NET Core project, and it's also going to have a CloudFormation template. In our code build stage, what we're going to be doing is we're going to be using our .NET CLI to run the .NET Lambda package CI command. What that package CI command does is it's going to do all of the .NET publish, zipping everything up, and it's going to upload that bundle to S3. It's going to update the CloudFormation template to point to that location, and then it's going to output that updated template. Now that updated template can then be passed on to our deploy stage, where we're going to use CloudFormation to create our change set, which is going to run our transformation, and then we're going to execute our change set. And that will actually update our Lambda function. Let's go take a look at how we can do that. Go back to the console. I'm going to switch regions where I've set a lot of this already up. And first, we're going to go to code build. Now, I've already set up the image resizer and the detect labels build project. So I want to set up the front end project now. So I'm going to click create project. We're going to call this the serverless front end. And we're going to use code commit for this. I've already checked in all my code, each one of these 3 separate projects into different code commit repositories. So we'll select our front end. And then we have to set up our build environment. Now I could create my own custom Docker image and use that, but we do also have a .NET Core Docker image already set up at code build. So we're going to select Ubuntu, .NET Core, and then choose the 2.0 version. Now, Docker code build uses a build spec YAML file that it's going to look for in our repository to find the instructions on how to run our build. Let's take a look at the build spec file we're going to use. Now ours is pretty simple. In the prestep, we're going to just do a .NET restore, which is going to go and bring us our .NET Lambda commands. We're going to switch into that front-end directory, and this is where we're going to call that .NET Lambda package CI command. And then we're going to specify what is the S3 bucket we want to use to store the artifacts of our application. So this is when, after we do the .NET publish and zip that up, it's going to go upload that bundle to this bucket. And then it's going to go update the serverless template in our project, all those code locations, to the location of the object in this bucket. And it's going to write that out to this template file here. So this is going to be the output of our project, as you can see here in the artifacts returned. Let's go back to our project here, our co-build project. So now we're going to specify where we want the artifacts of our co-build project to go. We're going to say S3, and we're going to put this in the serverless webinar front end. This turns out to be like a S3 prefix for the object key in that bucket. And then we need to specify our bucket. I'm going to have my .NET artifacts bucket. And then we need to give a role for code build to run. So this is what's going to provide credentials to our build environment to access. And for our case, we need to access S3 because we need to upload the bundle to our S3 bucket. We also need access to our code commit repository and CloudWatch logs for our logging. I can create a role here, but I'm going to use a role I already set up that has all those permissions I just said. And with that, we're just going to push continue. And we can review everything. Everything looks like we want. And just put save and build. And we can do a test build here, choosing our branch. It's going to go grab the latest commit on that. And we can start a build. And then that is going to go and start a build for us. Now, of course, that's just the build part. We want to actually have our whole pipeline set up. So let's go over to Code Pipeline and configure that. Again, we already have the detect labels and image resizer. Let's create the pipeline for our front end. So call this one Serverless Webinar. And we'll select our code commit repository as our source for our pipeline. And then for our build, we're going to say code build and select the build system that we just set up. And next we would set our deployment up. Now I'm actually going to say no deployment right now because in our project we need to actually have two actions set up as part of deploy, creating our change set and execute change set. And that will be easier to set up after our pipeline has been initially set up. And then we need to give our role for code pipeline to be able to access our source providers. So I'm going to use the pre-created one for us. We can review what we've set up. And our pipeline is created. Now our pipeline so far right now only is pulling in our source and running our build. We don't have the extra deploy setup. So let's go ahead and set that up for our system. We're going to edit this. Now before I do that, I want to show something in our build stage. In the output artifacts, it has this my app build. This is the logical name of the group of artifacts outputted out of this stage. And we're going to use that logical name to get us the input of our artifacts for our deploy stage. So let's start creating our deploy stage. Call it deploy or action. This is categories of deploy. And this is going to be create change set. And then our deployment, we're going to say is CloudFormation. And here's how we can say we want it to go and create a change set for us. We need to define a CloudFormation stack name that will be created by this. So this is going to be called our serverless webinar front end. And change sets have a name. So we're going to give our change set a name that when we execute our change set will refer to this name so it knows which change set to run. Now we have to say what is the input, the template that we want to run in here. And this is where that logical name I mentioned before comes into play. Because we want to say we want to pull in the myapp artifacts. And so we'll refer to that by saying myapps : and then the name of our template. And remember, our template is the updated one here. This is the updated serverless template that came out of our build system. Now, if our template is creating IAM roles, we need to say it has the capability to do that. And we need to give a role for CloudFormation to assume to create all those resources. I'm going to select the role that I've already set up for that. And so with that, we have now got everything we need set up for the action of creating our change set. We'll add that action. So now that's done. We could add an action to do a manual approval if we wanted to make sure that it was creating what we wanted. But we're just going to go ahead and start the execute change set. So again, we're going to say deploy execute change set CloudFormation, and now we'll select the execute change set option. We have to make sure we set the same name for our stack name as we did in the create change set, and the same change set name. And there we go. So we're going to create this serverless webinar front end, and it's going to use the change set name transform. And we'll add that action. Now, just to confirm I did that right in both places, we're going to look at the create one again, just to confirm serverless webinar front end transform. It's the name of the stack and the change set that's created, and the one that's executed, serverless webinar front end transform change set. All right, and that is it. We click save, confirm we want to do that. And now we have in our pipeline our deploy stage, which is a create change set and execute change set. And we can push the release change set button, or release change, to go ahead and restart our pipeline to go and have our stack being created for us. So we should see here, there's our pipeline started where the source is going to go in, it'll run our build, and then into our deploy stage. Now that'll take a couple minutes to go, so we're going to switch over to our pipeline that we set up already. So there's the one that we just set up, but this is the one I set up before today's talk, and we can see how that has all run. And we can click on the CloudFormation view here, And see, here is the CloudFormation stack that got created by our pipeline. Here's all the resources that were created. And like I said, that transform gets broken out into quite a few other resources. And in our output, we have our URL, and we can click that. And here is all of our images that have been created through our pipeline on all throughout Serverless. Okay. Another alternative for .NET users is we have the AWS Tools for Visual Studio Team Services. This is a collection of tasks that you can add to your VSDS pipeline or Team Foundation service to do a lot of the similar things that we saw in our code services as well. And with that, thank you very much for listening. Again, my name is Norm. I'm a frequent contributor to the AWS.NET Developer blog. These are a lot of the GitHub repositories that I work on, and they're excellent places to go reach out for if you need help with AWS and .NET.